So the last bit of code that we wrote at the end of the previous video may well horrify Java and C programmers. So let's just go down and look at that code again. So I'll start by reviewing it. So make sure you've opened the Hello World project in your IDE if you haven't got it open and you've got the strings.py open. So firstly, on line 14, we've attached the variable age to an int value 24. Further on, down on line 20, we've reattached that same label to a string value 2 years. Age at that point is now bound to the string 2 years. So Java and C programmers might jump to the conclusion that Python is a weakly typed language and doesn't care what type things are. And that's a natural assumption if you think in terms of assigning a value to a variable. Looking at it that way, it looks like we've assigned a string value to an int variable. Age represents an int on line 14, but is given a string on line 20. If we think in terms of binding a variable to a value, things make more sense. On line 14, age is attached to an int value, 24 is an int and will always be an int. When we rebind the label age to a string value on line 20, we're saying that we no longer want that label to refer to an int. We now want to use it to refer to the string value 2 years. Now reusing a variable name like that probably isn't a good idea. It can make your code confusing to read. What we probably should have done is bind a more meaningful label to the string. So something like, we come back to line 20, age underscore in underscore words. That would now be more obvious as to what we're trying to do here. But just because Python allows you to reuse a variable name for a different purpose, that doesn't mean it's not strongly typed. As an example, let's see what happens if we try to add an int to the string. So I'm going to modify line 21 here. Instead of just printing age, we're going to delete that and we'll put name plus double quotes space is space and double quote closing double quote plus age plus and double quotes again space then years old. So we saw string concatenation on line 11. Python knows that greeting and name are bound to strings and can happily concatenate the string values to print out the full greeting. So I've just modified line 21 and now we're mixing string and int values. Will it work? Well, let's run it to see. So you can see when we ran it, I'll scroll up so we can see the errors. It prints the two greetings and the value of age, but then displays an error. So the error you can see there is type error, and that's all happening on our code on line 21. Python helpfully shows the line number. We can scroll over and see there, line 21 in module. And it also shows the bit of code that displays the error, as well as a description for what the actual error was. So a type error means that we've provided a value of one type, int in this case, when it's expected another type, a string. So different versions of Python produce slightly different descriptions for that error, by the way. I got the message can only concatenate string, not int to string, as you can see on the screen there, but your version of Python may have said can't convert int object to string implicitly. Python knows what to do if you use plus with two strings, it concatenates them, or with two numbers, it calculates their sum. However, it's got no idea what you intend if you try to add a string and a number. Some languages, such as Java, will automatically convert the number to a string and concatenate, but Python doesn't do this, hence the type error. Automatic type conversion can be useful, but it can also be a source of hard to find bugs, and Python tries to prevent you from introducing errors in this way. Now later in the course we'll look at handling errors, but for now, think of errors as your friend. When Python displays an error like the one above, it's telling you that your code won't work. It provides as much information as possible to help you work out why as well. Errors may be frustrating, but you'll learn a lot from getting errors like this, and more importantly, working out how to fix them. An advantage of using an IDE like IntelliJ IDEA or PyCharm, rather than the idle IDE that ships with Python, are the hints that IntelliJ provides. So at the far right to line 21, I'll just close this run window down. I'll hover over that. You can see that little yellow dash that I hovered over. IntelliJ is now showing a tooltip saying expected type string, str, but got int instead. This is a good indication that something is wrong before you even run your program. So if your IDE provides warnings and errors like this, they're extremely useful if you check them out when you make simple typing errors in long programs. Alright, so I'll stop the video here, and then the next one we'll look at Python's numeric data types. See you in the next video.